Let's look at two empirical examples of cross-lags using this RICLPM methodology. We're actually going to take kind of a deep dive here. So in this study, a cross-national sample of kids was repeatedly measured on number transcoding, which is a process by which we translate numbers from one format of representation to another. For example, seeing the written word 600 and being able to turn it into the numeric representation 600 in our heads. They were also repeatedly measured on number facts, which are basic addition, subtraction, multiplication, and division calculation that children should learn to recall instantly with no working out. In other words, they need to learn them off by heart, or basic times tables. This paper did more than cross-lags, but I'm just focusing on the cross-lags here. They did RICLPM, and I thought this summary paragraph was actually worth reading together. One criticism of the standard CLPM approach is stable differences between individuals over time cannot be estimated separately from changes in measures within an individual. As a consequence, it's difficult to determine the degree to which bidirectional patterns of longitudinal association between two measures, transcoding numbers and number fact speed, for example, can be attributed to changes that occur within individuals or relative changes between individuals. A random intercept cross-lag panel model has been proposed, which extends the CLPM analytic process by separating within-person variability from between-person variability. The autoregressive parameters reflect within-person stability in measures over time. For example, greater number fact fluency for an individual at one time point may predict greater number fact fluency at a subsequent time point, whereas cross-lag parameters reflect the degree to which changes in one measure are predicted by prior deviation from an individual's own score on another measure. For example, the influence of number transcoding accuracy on number fact fluency over time within an individual. And here is a nice way in which they laid out their rationale for this model. They said, we use RICLPM to test the hypothesis of a bidirectional pattern of association within children's number coding accuracy and number fact speed over time. Cross-lagged and autoregressive parameters were freely estimated to determine whether number reading was a stronger predictor of number fact speed or vice versa. A between-person correlation was also expected between these measures, which would suggest individuals faster at solving number fact problems were more accurate at transcoding number symbols and vice versa. This, too, I wanted us to be really ready because it makes what we just reviewed so concrete. Two types of parameters are specified in CLPMs, autoregressive and cross-lagged. Autoregressive parameters estimate the rank order stability of individuals' relative positions between test occasions and reflect the extent to which variability in one measure at the current time point, for example, number fact fluency at age 7, can be explained by variability in the same measure from the immediately preceding time point, for example, number fact fluency at age 6. The cross-lag parameters estimate the degree to which variability in one measure at a time point, for example, number fact fluency at age 7, can be explained by variability in a different measure at a preceding time point, for example, reading numbers at age 6. And so here is the model. We see that they pulled out a transcoding intercept and a number facts intercept. And then they estimated autoregressions and finally cross-lags, again here with no constraints. They noted that there was a significant between-person or intercept factor correlation of minus 0.784, meaning that children who could correctly transcode increasingly larger strings of multi-digit numbers were also faster to solve single-digit addition problems. But the concurrent relationships between number fact and transcoding were not correlated at the within-person level over time. From the autoregressions, they concluded that there was greater stability within the patterns of increase in children's transcoding over time compared to greater variability within patterns of children's number fact performance. Next in the text, in the middle paragraph, it notes that the cross-legs showed a bit of time-to-time variability, such that number facts and transcoding predicted each other in cross-legs between time 1 and 2, but only transcoding predicted number facts at time 3. The bottom paragraph is interesting because they also tried another model where they constrained the cross-legged and autoregressive parameters to be the same over time, but this fit worse than what they showed on the previous slide. They interpreted this as meaning that the bidirectional relationship between transcoding and number fact changed over time. They also did another model, implied by the paper title, that looked at how various covariates predicted stable between-person differences, the intercept factors, of both number facts and transcoding. I put that up to show you that it is possible, and it is one of the extensions I'm ignoring, but the URL I talked about earlier shows code for how to do that. But since that goes beyond simple cross-legs, I'm going to stop here with this example. Let's look at one other quick example. Here we have an RICLPM looking at a self-related feature. We're going to focus on one called perceived competence and its cross-legged relationship with quiz performance as a measure of academic achievement. In other words, does quiz performance predict subsequent sense of competence, or does feeling competent predict better quiz performance? So this is represented differently, but this is the classic cross-legged panel model with no random intercept. Here the Greek symbols imply that they're imposing equality over time. And here, even though this diagram is a little different than we're used to, this is the RICLPM, where they pull out latent intercept factors of quiz and self-related perceived competence at the left, and then do the autoregressions and cross-legs on the residuals. Again, equal Greek letters imply invariance over time. The left is the classic CLPM. The right is the RICLPM. And what they found was this: autocorrelations across all measures were substantial and statistically significant in the CLPM. However, in the RICLPM, the substantive magnitude of these autoregressive parameters was attenuated substantially for self-competence. The autoregression for quiz was fully attenuated, meaning no longer statistically different from zero in the RICLPM. This indicates that most of the stability reported in the CLPM is between-person variance. In terms of the main research focus, examining the cross-legged parameters also indicated substantial differences between the CLPM and RICLPM. In the CLPM, self-competence was a significant driver of quiz score. However, in the RICLPM, self-competence was no longer significantly associated with quiz score. Quiz performance was significantly related to self-competence in both models, but the effect of quiz on self was lower in the RICLPM. The argument they're making then is that once you pull out the between-person variability, which is what differs between the left side, which didn't pull it out, and the right side, which did, you're left with much smaller or attenuated autoregressions and cross-legs. But now, presumably, These are more meaningful because they don't confound between and within person variability. And from that, given that self-competence significantly predicted quiz performance at the next occasion, but quiz performance did not predict self-competence at the next occasion, this asks us to believe that sense of competence is a lead indicator and quiz performance is a lag. In other words, your perceived competence predicts how well you'll do on the quiz. So if we should probably intervene, we should do it on your self-perception if we also want to improve your quiz score. One final point on this, notice that they're doing a head-to-head comparison of the significance of parameters across the two models, but not asking the chicken-egg question in terms of, is one of these B weights bigger than the other? And as I've said a few times now, to my mind, that is problematic always, but impossible to do unless the measures are in a common metric. But before we leave this topic, I want to show you one much discussed Twitter thread that emerged around the time that I was doing these slides. It's important to notice that Rick Lucas's objection is more to the classic CLPM, and he even acknowledges at some point that the RI CLPM solves the problem. But let's quickly read through this thread because it is a nice, efficient summary. Just posted a new preprint arguing that it's time to stop using the cross-leg panel model. Would love to hear comments. I'll highlight a couple issues in this thread. First, it feels a little weird to write this paper. On the one hand, most people in my timeline will probably see the arguments and conclusions from this paper as completely obvious. There are already many really good, highly technical critiques of CLPM. At the same time, I continue to see and review papers that use the CLPM. These papers often cite recent defenses of a CLPM, defenses that I think have problems. I try to address those problems while also providing some new ways to frame the limitations of the CLPM. One issue is that critiques of CLPM often focus on the fact that alternatives like the RI, CLPM, or STARTS are multi-level models that separate between person effects from within person effects. I agree that this is important, and I rely on this argument in my paper. But the whole between versus within issue is complicated and confusing. I think the meaning of these terms is often ambiguous, and different multi-level models accomplish the goal of separating levels in different ways, leading to confusion about what the RI CLPM does. So, in addition to discussing the multi-level issue, I also try to consider other ways of thinking about the problems of a CLPM. For me, the issue is this. When testing the associations among two variables assessed at 2 or more times, the CLPM simply cannot distinguish between these two extremely plausible models. In other words, if there is some stable trait variance that underlies X and Y, and for most things we study there probably is, then it's easy to find support for the idea that time 1x predicts time 2y controlling for time 1x, even if there is no true over time effect. I use simultaneous equations to show that it's extremely easy to find spurious cross-lagged paths, even under very realistic scenarios. For many of these, the probability of finding a spurious cross-lagged effects hits 100%. For example, this shows the likelihood of finding significant cross-lagged paths even when they are actually 0 for a two-wave design when reliability is 0.7 and 50% of the reliable variance is stable trait variance. Lines reflect different R's between the stable traits. In longitudinal studies, more waves are better, right? Here is the same simulation, but now with 5 waves of data. So features that are supposed to be good, larger N, more waves, even higher reliability in some fortunately rare cases, can increase the likelihood of finding spurious cross-lagged effects. I also created a Shiny app that lets you simulate data for 2 variables over time, and then test how the issues discussed in the paper impact estimates of the cross-lag paths. I wanted to note that I don't usually use titles that are quite so opinionated, but after considering the issues, I really can't think of a situation where the CLPM would ever be useful. With 2 waves, CLPM is the only option, but it's uninterpretable. With more waves, there are better options. More complex models do sometimes have estimation problems, but that doesn't mean that the simpler model is interpretable. Sometimes the data just don't allow for conclusion. If there is a situation that I've missed where it would be useful, and I really am open to hearing them, I'll reconsider my title. I also highlight what I think are interpretational errors in previous defenses of a CLPM. The papers I critique are sometimes by friends and people I respect. If I've mischaracterized these issues or made my own mistakes, I definitely want to know about and correct them. This might be a worthwhile preprint or eventual published paper for you to have a look at. Okay, let's make one last topical shift for the week because it sets us up for next week.